Airplanes are amazing. They allow us to travel the world. We can cross oceans and continents in hours. This was once unimaginable. Before airplanes, long journeys took weeks or even months. The invention of the airplane revolutionized travel. It made the world smaller. People could experience new cultures. Goods could be transported faster. The airplane brought people and places closer together. The science behind flight is fascinating. It involves a delicate balance of forces. These forces work together. This is what allows a heavy machine to lift off the ground and soar through the air. To understand how airplanes fly, we need to understand 4 fundamental forces that act upon them during flight. These forces are crucial in determining whether an airplane can take off, stay in the air, and land safely. These forces are lift, weight, thrust, and drag. Each of these forces plays a unique role in the dynamics of flight. Lift is the force that pushes the airplane upwards, counteracting the weight, which is the force of gravity pulling it down. Thrust propels the airplane forward, while drag resists this motion, slowing it down. These forces act on the airplane continuously and determine if it stays up in the sky or falls back to the ground. The balance between these forces is what makes flight possible. Lift is generated by the wings of the airplane. As the airplane moves forward, air flows over and under the wings, creating a difference in pressure that lifts the airplane into the sky. The shape of the wings, known as the airfoil, is designed to maximize this pressure difference and generate sufficient lift to keep the airplane aloft. Weight, on the other hand, is the force of gravity acting on the airplane. It pulls the airplane down towards the earth and must be overcome by lift for the airplane to ascend. When the airplane descends, it is because the weight is greater than the lift, causing it to lose altitude and eventually land. Thrust is the force that moves the airplane forward. It is generated by the engines, which can be jet engines or propellers, depending on the type of aircraft. The engines work by expelling air or exhaust gases at high speed, propelling the airplane in the opposite direction, according to Newton's third law of motion. Drag is the force that opposes the airplane's motion through the air. It is caused by air resistance and acts in the opposite direction to thrust. The shape and surface of the airplane, as well as the speed at which it travels, affect the amount of drag it experiences. Pilots and engineers work to minimize drag to improve efficiency and performance. For an airplane to fly, lift must be greater than weight, and thrust must be greater than drag. This delicate balance allows the airplane to climb, cruise, and maneuver through the sky. During takeoff, the engines generate maximum thrust to overcome drag and lift the airplane off the ground. Once airborne, the pilot adjusts the controls to maintain a steady climb. When these forces are balanced, the airplane can fly smoothly and efficiently. The pilot continuously monitors and adjusts the controls to ensure this balance is maintained. This is a delicate balance that requires constant attention and adjustment. The pilot uses the plane's controls, such as the ailerons, rudder, and elevators, to manage the forces acting on the airplane. It is maintained by the pilot, who must be skilled and knowledgeable about the principles of flight and the behavior of the aircraft. They use the plane's controls to adjust the forces, ensuring a safe and efficient flight. Understanding these forces and how they interact is essential for anyone interested in the science of aviation. Engines are the heart of an airplane. They provide the thrust needed to lift the massive structure off the ground and keep it soaring through the skies. Without engines, airplanes would be nothing more than grounded metal birds. This propels the airplane forward, allowing it to gain the necessary speed to achieve liftoff. The runway becomes a stage where the power of the engines is showcased. There are different types of engines, each designed for specific kinds of aircraft and purposes. From the powerful jet engines of commercial airliners to the propeller engines of smaller planes, the variety is vast. But they all work in a similar way, converting fuel into mechanical energy. Engineers and mechanics work tirelessly to ensure these engines are in perfect condition, as even the smallest malfunction can have significant consequences. They burn fuel to create energy. This process involves a complex series of reactions that release a tremendous amount of power, enough to propel an airplane weighing hundreds of tons. Most airplanes use jet engines, which are incredibly efficient and powerful. These engines have revolutionized air travel, making it faster and more reliable. Jet engines take in air at the front. This air is then compressed and mixed with fuel in the combustion chamber. They mix it with fuel. This mixture burns at extremely high temperatures, creating a high-pressure environment. The burning creates hot gas, which expands rapidly. This expansion is what drives the turbines and generates thrust. This gas is forced out of the back of the engine. This creates thrust, pushing the airplane forward with incredible force. The faster the gas is expelled, the greater the thrust. This principle is fundamental to the operation of jet engines. This is Newton's third law of motion in action. For every action, there is an equal and opposite reaction. For every action, there there is an equal and opposite reaction. The force of the gas being expelled out the back of the engine pushes the airplane forward. The force of the gas going out the back of the engine pushes the airplane forward. This is the essence of flight, a marvel of engineering and physics working in perfect harmony to conquer the skies. Wings are the key to flight. They are specially shaped to create lift. The shape of a wing is called an airfoil. The top of the airfoil is curved. The bottom is relatively flat. When air flows over the wing, it has to travel farther over the curved top. This faster air on top creates lower pressure. The air under the wing moves slower. This creates higher pressure. The difference in air pressure creates lift. This difference in air pressure pushes the wing up. This is what lifts the airplane into the air. The faster the air flows over the wing, the greater the lift. This is why airplanes need to reach a certain speed to take off. Section 5. Newton's Laws in Action, Physics of Flight. In this section, we will delve into the fascinating principles that allow these massive machines to soar through the skies. Understanding the physics of flight is not just about knowing how airplanes work, but also about appreciating the intricate balance of forces that make it possible. Newton's laws of motion explain how airplanes fly. These laws, formulated by Sir Isaac Newton in the 17th century, are fundamental to our understanding of physics and are crucial in the field of aerodynamics. They describe the relationship between a body and the forces acting upon it, and the body's motion in response to those forces. Newton's second law states that force equals mass times acceleration, or F equals ma. This law is particularly important in aviation because it helps us understand how much force is needed to move an airplane. The larger the mass of the airplane, the more force is required to accelerate it. This means that the heavier something is, well, the more force it takes to move it. For instance, when an airplane is loaded with passengers, cargo, and fuel, its mass increases significantly. Therefore, the engines must generate a substantial amount of force to achieve the necessary acceleration for takeoff. In the case of an airplane, the engines provide the force. These powerful engines work by burning fuel to produce a high-speed stream of exhaust gases. This process generates thrust, which propels the airplane forward. This overcomes the plane's mass, allowing it to accelerate and take off. As the airplane speeds down the runway, the increasing velocity generates lift, which is the upward force that counteracts the weight of the airplane. Once in the air, the lift generated by the wings counteracts the force of gravity. The wings are designed with a special shape known as an airfoil, which creates a pressure difference between the upper and lower surfaces. This pressure difference produces lift, keeping the airplane aloft. This, in turn, keeps the airplane aloft. The balance between lift and gravity is crucial for stable flight. Pilots must constantly adjust the controls to maintain this balance, especially during changes in speed, altitude, and weather conditions. Newton's third law is also important. This law states that for every action, there is an equal and opposite reaction. In aviation, this principle is evident in the way engines generate thrust. As mentioned earlier, it states that for every action, there is an equal and opposite reaction. When the engines expel exhaust gases backward, the airplane is pushed forward with an equal and opposite force. This is the fundamental principle behind jet propulsion. This is how engines generate thrust. The high-speed exhaust gases create a forward push, propelling the airplane through the air. This thrust must be sufficient to overcome both the drag, which is the resistance of the air, and the weight of the airplane. The force of the gas being expelled from the engine pushes the airplane forward. This continuous expulsion of gases ensures that the airplane maintains its speed and altitude. Understanding these principles not only helps in designing more efficient aircraft, but also in improving flight safety and performance. Section 6. Taking to the skies, how airplanes take off. Takeoff is the most exciting part of a flight. This is when the airplane transitions from the ground to the air. To take off, the airplane needs to generate enough lift and thrust. The pilot increases the engine power. This provides more thrust. The airplane accelerates down the runway. As it gains speed, the air flows faster over the wings. This creates more lift. When the lift generated is greater than the weight of the airplane, it takes off. The pilot then retracts the flaps. These are extensions on the wings. They are used to create more lift during takeoff. Section 7. Cruising altitude, smooth sailing in the air. Once the airplane reaches a certain altitude, it enters cruising altitude. This is the most stable part of the flight. The airplane flies at a constant speed and altitude. The four forces of flight are balanced. The engines provide enough thrust to overcome drag. The wings generate enough lift to counteract weight. The pilot makes minor adjustments to the controls. This ensures the airplane stays on course. During cruise, the airplane is most fuel efficient. It is not climbing or maneuvering. This allows it to conserve fuel for the rest of the flight. Section 8. Back on the ground. The art of landing. Landing is the most challenging part of flying. It requires precision and skill. The pilot has to reduce the airplane's speed and altitude. They have to make sure it touches down smoothly on the runway. The pilot extends the flaps again. This creates more lift and drag. This helps to slow the airplane down. The pilot also decreases engine power. This reduces thrust. As the airplane descends, the pilot uses the controls to adjust the pitch and roll. This ensures a smooth landing. Once the wheels touch down, the pilot applies the brakes. The airplane comes to a stop. Section 9. The future of flight innovations on the horizon. The field of aviation is constantly evolving. Engineers are always looking for ways to make airplanes safer, more efficient, and more environmentally friendly. One area of focus is the development of new materials. These can be used to build lighter airplanes. Lighter airplanes require less fuel. This reduces their environmental impact. Another area of research is in the field of aerodynamics. Engineers are designing new wing shapes and new aircraft designs. These can further reduce drag. This can make airplanes even more fuel efficient. The future of flight is full of possibilities. With continued research and development, we can look forward to even more amazing advancements in aviation.